Hello guys! This video we will talk about the static root principle. As we know, all the devices of the router and the layer 3 switch for the message out, we need the IP routing table. In the table, we have three types of routing information: the direct route, the static route, and the dynamic route. And we already know how to configure the direct route, right? Give the IP address and make the interface the state to become up. Then we can get the direct route. But if we have lots of segments and we have lots of devices, how to know the segment information of the other devices? One solution is by the administrator, and then the administrator will give us the static route. So we can use the command to make one segment, the second segment, all the segments except the direct route. So what's the key configuration, what's the key command, and what's the key point we have to know if we deploy the static route? If you want to know it, please follow me together. Thank you.
Hello guys, this video we will talking something principle about the direct routing and the static routing. Because about the last video we already know if the router want to help us for the message between different IP segments, we need the IP routing table. And in the table we can have lots of entries information to show you which segment you can send to it. And we have three source type, right? Direct routing, static routing, and the dynamic routing. So about this video, we will talk about the first two parts, direct routing and static routing. And about the direct routing, it's very easy. If the router wants to get the root of the direct network segment without any root configuration, but pay attention, here we see no any configuration about the root, but we still have to add some configuration like the IP address, right? And this is the basic one if you want to get the direct routing. And if you give the IP address and also can match some requirement like the physical status to become up, the protocol status also become up, then you can get the direct routing information. And then some basic message transmission like the traffic in different VLAN, we can use the direct route to help us for the message. So this is a basic definition why we need the direct routing and what's the function. But if you have multiple links and not directly connect with one router, the other segment we need the rest way to let the router know the link information. One is static. If you choose the static way, all the static routes have to be configured manually by the administrator. And also, if the network topology change, for example, you add some link or maybe delete some link, or maybe some devices is broken, all the network topology change. This link information you have to config, delete, or maybe add by the administrator manually. So if you want to deploy the static route, only can be used in the simple topology. This is the static route and the direct route. First, let's see the direct connected routing. If you want to get this routing information for router or maybe for layer 3 switch, we have some requirement. The first one, you have to give the IP address configuration for layer 3 interface on the device. Includes the layer 3 switch, you have to change the mode to become layer 3 interface. Also, about the router, you have to give the IP address. This is the first requirement. And about the second one, the state of the physical layer and the data link layer of the interface should be up. Maybe when you do the configuration to give IP address for the devices, then you will use some command to check the interface status, show IP interface, right? And here are two status, one about the physical layer status and another one for the protocol layer status. Both of them, the status are up, then you will get the direct route. And you use the command show IP routing brief, you can see the direct routes indicates all the network segments that belong to all the interface connect with the router. And this direct routing will directly exist in your routing table. And pay attention please, when you do the configuration of IP address about the router, you will give the special IP address like 1.1.1.1 and give the mask, maybe it's 24, right? But finally, when you see your IP routing table, you will see the network address to indicate the whole network segment. You will find the result is 1.1.1.0/24. So that's why when we talk about the IP address plan, we say the network address cannot be assigned by the customer or maybe by the network interface because this address have a special meaning. We will use the network address to indicate the segment. So here is an example for like this topology. If we have a router and route 1 and connect with switch A, switch B, and maybe also connect with a hub. And about the access switch and the hub, we also connect with lots of terminals. And now we already give the basic configuration like the IP address, the gateway address of all the terminals. And about the switch and the hub, you only need to give the power and use a cable to connect with all the devices. It's enough. If you don't do any plan about the VLAN, right? You only use a cable to connect with the interface, it's enough. And then about the router, we also give the IP address. And like the Ethernet 00, the IP address is 192.168.1.254/24. And the rest interfaces will also give the IP address. So after you finish the configuration, when you use the command to check the IP routing table on route 1, you will find 3 direct routes. And now if the message should be forwarded between the left PC 192.168.1.100 to wait the destination to the right terminal 10.10.1.100. And the message will send to route 1. When route 1 receives it, I will check my routing table and I can find the destination IP address belongs to the same segment of the direct route. So I will direct it to do the re-encapsulation again and send out of the Ethernet 0/2 to the destination. So this is a basic function about the inter-LAN routing. And about the administrator, it's very easy. Give the correct IP address and the gateway of the terminals, and give the correct configuration of the physical interface IP address. Then the routing will get the direct routing automatically. And after we use a tool like the ping to test the connection between different terminals, the terminal will do the encapsulation automatically. And also will send out the ARP request message to get the gateway MAC address automatically. And when the router receives this message, I will delete the layer 2 information, take the destination IP address to match your IP routing table. This process also will be done automatically. Then I will send out the ARP request message to the destination to get the MAC address because I have the direct routing to connect with the destination IP address. And this process also is automatically. Then the route 1 will do the encapsulation again and select the outer interface Ethernet 0/2 and to the destination. So about this process, they will do automatically. You don't need to do any configuration. The basic one is give the correct IP address, give the correct mask. That's all. So about the direct routing, it's very easy. If you keep the state of the physical interface is up and give the correct IP address, it's enough. So this one is a basic one. If we use a router to finish the packet forwarding between different LAN, and we don't do any plan about the VLAN, right? So this is a basic one. And another application about the direct routing, maybe when we talk about the principle of the VLAN, we know why we need the VLAN. We want to divide the broadcast domain. If some terminal send out the broadcast message, only someone receives this broadcast message, not everyone. So in this scenario, we will use the technology of the VLAN. If we divide the VLAN, the terminal in the same VLAN, they can directly visit with each other. But if some message belong to different VLAN, but they still need to forward the message to the other VLAN, in this scenario, we need some Layer 3 device to support. That means we need the routing information to support for the message out. So who will be the Layer 3 device? The first one we will find is a router, right? So now let's see if we deploy a router and about the switch we use a VLAN, how to forward the message between different VLAN. Like this topology. And about the layer 2 switch, I make the switch bigger and to know the detail principle. About the layer 2 switch, now we have 3 VLAN, VLAN 10, VLAN 20, and VLAN 30. And each VLAN now we connect with PC, PC1, PC2, and PC3. And all the terminals already get the IP address and the gateway. Then if the PC1 and PC2 want to do the communication with each other, because they belong to different VLAN, right? One belong to VLAN 10 and another one belong to VLAN 20. So now we will use the Route 1 to provide the communication. And about the Route 1, we will use 3 physical interfaces and to connect with the switch and give the IP address, and this 3 IP address is a gateway of the PC1, PC2, and PC3. And now let's see the process. If PC1 want to send the message out, PC1, the source IP address is 192.168.1.100, and the destination IP address is PC2, 172.16.1.100. And the source MAC address also is PC1 MAC address. And the destination MAC address should be gateway IP address, right? Do you still remember the principle? If the terminal wants to send out the message, and the first step, I will check the destination IP address with my IP address in the same segment or not. Now we will find PC1 and PC2's IP address is different. So PC1 will send out ARP request message to ask my gateway, please tell me what's your MAC address. And after get the MAC address, I will do the encapsulation. Add the R1 Ethernet 00 interface this MAC address to be the destination MAC address of the ICMP message. Then this message was sent to L2 switch, right? And about the L2 switch, because I received the message from the first interface to connect with PC1, and this interface already added the VLAN of VLAN 10. So in the switch, this message carries the VLAN 10 message, VLAN 10 tag, and then we will find the red line to connect with the Route 1. This interface also belongs to VLAN 10. So finally, this message will be sent to Route 1 and delete the VLAN target information. And pay attention, in this topology, all the interface connect with the terminal or maybe connect with the router. The interface type is access interface. Because about the router and the switch and the terminal cannot recognize the VLAN ID information. So the message will be delete the VLAN 10 and send to the R1. Then when R1 receives this message, I will find that the destination MAC address belongs to my physical interface, so I will delete this layer. And then I will find The destination IP address is 172.16.1.100, right? And I will take this destination IP address to match my IP routing table. And now I have 3 direct routing. And my outer interface Ethernet 0/1. This interface IP address is the same segment with the packet's destination IP address. So I will know this message that needs the router to forward out. The destination IP address is the same IP segment with my direct routing. So I will directly send out the ARP request to PC2. Please tell me what's your MAC address. And then PC2 will give a reply. When Route 1 receives this message, I already know what's the destination MAC address of the PC2. So I will do the re-encapsulation again. And the source IP address is the PC1 IP address. Destination IP address is PC2 IP address. Source MAC address is the interface of Ethernet 0/1, and the destination MAC address is PC2. And finally, the message will be sent out of the Ethernet 0/1 to the layer 2 switch. And the layer 2 switch will add the VLAN of VLAN 20. Because now the message carries the VLAN 20, so finally the message will be sent out to PC2. So this is a whole step, how to forward the message between different VLAN. And if we use the router in our network, we can solve this problem if the message needs to be forwarded between different VLAN. But the disadvantage is the router establishes a physical connection to each VLAN, which will waste a large number of ports. Because by default, about the VLAN, we can create 4094, right? And about the router, we have less physical interface compared with the layer 2 switch. That means if in your network you have 10 VLAN, we at least have 10 layer 3 interface to support the communication between different VLAN. So this is the disadvantage. So how to make the solution better? We also have the other one. We call it still use the router on a stick way. And then we can see this topology. Why we need 3 physical links to connect with router? That's because the router cannot recognize the VLAN ID by default about the physical layer. So before we send out the message to Route 1, we must delete the VLAN. By each different VLAN, we have to set the interface type to become access interface. That's why one VLAN at least one physical interface to connect with Route 1. If now we use this technology, and we can create multiple sub interface about the router layer 3. About this sub interface, we can add the command to let the router know that this message carries a VLAN target is 10, and then you can let the VLAN 10 sub interface to deal with this message. And the other one maybe carries a VLAN 20. You can send this message to the 2 sub interface to deal with this message, something like this. So in this solution, we only need one physical link is enough, and we can create 3 sub interface and give the IP address, and then we can get 3 direct routes. And also about the sub interface 1, 2, 3, we can let them to recognize the VLAN 10, VLAN 20, and VLAN 30. Another different one for the layer 2 switch. All the interface connect with the terminal still use the access interface, but the interface connect with the router, we have to change it to become the trunk. And about the trunk, we have to allow all the devices, all the VLAN pass through. Then the same scenario, PC1 want to communicate with PC2. When PC1 send out the message, layer 2 receive it. I will add the VLAN 10, and this message will be carried out through the will be sent out through the trunk interface and carry the VLAN 10 information because now we use the trunk type. And because now we and the VLAN is VLAN 10, and the MAC address is the subinterface of the Ethernet 00.1. So this subinterface will deal with the message, delete the layer 2 information, and do the recapitulation. Before we recapitulation successfully, we also need to send out the ARP request to get the PC2 MAC address, because the second subinterface is directly routing information connect with the PC2. So in this solution, we will find the process is very similar like the physical link to connect with the router, but the different one is we use one physical interface is enough. Physical link is enough, and we will create 3 sub-interface. This is a logical interface. And then this sub-interface can recognize different VLAN. Although maybe you will have 10 VLAN in your network, you can use 10 logical interface to analyze and to recognize the VLAN information from different terminal. So in this scenario, we say the advantage is one physical link and one physical interface it's enough. But the disadvantage is if this link or maybe this physical interface is broken, the network between different VLAN communication will be broken. So this one we call is a single failure in our network. So someone say we also need the better solution to meet the requirement between different VLANs. And now we usually will use the layer 3 switch. And about the layer 3 switch, you can think we can combine the router function and the layer 2 switch function together. According to the router function, we can provide the IP routing table to help the terminal forwarding the message between different IP segments. And when we receive the message, we also can match the IP routing table. And about the layer 2 switch function, we also can forward the message according to the layer 2 information if this message within the same VLAN. So we can combine this function together to become a layer 3 switch. About the layer 3, this is a definition. We can integrate layer 2 switching within the VLAN and also can provide the inter-VLAN routing and forwarding functions. And about the layer 2 switching is based on MAC address, right? And this process implemented by the hardware, so it can provide lower latency. We can find if the message is within the same VLAN, they will be forwarded faster. And about the layer 3 switching is based on the IP address and use hardware ASIC technology to achieve high forwarding speed. So this is a layer 3 switching. Of course, we say layer 3 switching based on the IP address forwarding. That means this message needs to be forwarded between different IP segments. If the message still within the same IP segment, we can use a layer 2 function, use a hardware to help us forward the message out. So this is the definition. And later, let's see an example. If now we have the topology and we give the configuration of the IP address and the basic interface configuration of the layer 3 switch, how to forward the message successfully. PC1 and PC2 connect to same layer 3 switch in different VLANs, one for VLAN 10 and another one for VLAN 20. The process of paying PC2 from PC1 is as follows. First, about the layer 3 switch, we create 2 SVI interfaces, VLAN 10 and VLAN 20, and also give the IP address 192.168.10.1/24 and another one for 20.1/24, and the MAC address, one for VLAN 10 and another one for VLAN 20. So this is a basic IP routing table, but pay attention. In the real network, your IP routing table, you cannot see the MAC address information. MAC address information located on the MAC address table. But here, in order to let you know the principle, how to forward the message between different VLANs, I add these parameters in the IP routing table. So these parameters in the real IP routing table are not exist. Pay attention, please. And then the IP address gateway of the PC1 and PC2, something like this. And at the beginning, about the layer 3 switch, the ARP table and the MAC address table are empty, right? Because I don't receive any message from our network, so this table will be empty. And now the PC1 determines that PC2 is not in the same subnet. For example, on the PC1 now, we will use the ping 192.168.20.2 and enter. Then the PC1 will do the encapsulation. Before we encapsulate successfully, we will check that the destination IP address with myself is in the same segment or not. Now we will find they belong to different segment. So the PC1 will send out the ARP request, and this function is to get some correct MAC address, and this MAC address from the gateway, because now PC1 and PC2 not in the same subnet. Then when layer 3 switch receives the ARP request, we have two actions. The first one, I will add the recording of the PC1 information, because later when I forward the message to PC1, I can directly use this message to do the encapsulation. 192.168.10.2 connect with MAC address PC1. And then I also will add this MAC address information into the MAC address table. Maybe in the future, also someone want to send out the message according to layer 2 information. So I also can directly to check my MAC address table. This is the first action to learning some packet information. And then I will send out the reply, because the ARP request message is used to ask the MAC address of the gateway, right? So I have to give you a reply. And this reply will show you what's your gateway MAC address. Now my MAC address is MAC address -10. And also will update the ARP entry and MAC address table. About this process we already explained before. Then let's see the next step. After PC1 gets the ARP information from the switch, then we will encapsulate the ping message, right? And about the ping, we will use the ICMP equal request message to test the network connection. So I will send out this equal message. The source IP address is PC1 IP address. Destination IP address is PC2 IP address. The source MAC address is PC1 MAC address, but the destination MAC address is the PC1 gateway MAC address. So this message will be sent to L3 switch. Then when we receive this ICMP equal request message, we will find the destination MAC address belongs to one interface of layer 3 switch, right? So I will delete the destination MAC address and the source MAC address to check the layer 3 information. Then we will find about the destination IP address is 192.168.20.2, and when we check the layer 3 forwarding table, there is empty. Pay attention about the routing part. We can divide into control plane and forwarding plane. In the forwarding plane, we can directly get everything to encapsulate the message. But this message is the first time I receive from the PC1. So about the forwarding plane, this is empty. So I will search the software routing table. Your IP routing table belongs to the software routing table. And then, according to the destination IP address, I can match the direct routes. Because about the layer 3 switch, we have two direct routes, right? And now I know I can help you to forward the message to the destination, but I also need to do the encapsulation successfully. So the layer 3 switch will send out the ARP request message to ask the destination IP PC2, please tell me what's the MAC address, right? And then PC2 will give a reply. My MAC address is PC2. Then the layer 3 will do the encapsulation successfully to make the IP equal request message sent to the PC2. And later, the PC2 will give a reply. And this is the process. Of course, about the layer 3 switch, after we receiving the ARP message from the PC2, the switch also will add the information connected with the PC2, includes the ARP information, what's the MAC address and what's the IP address, and also add the MAC address information into the MAC address table. So in the future, if I still receive some message to PC2, I can directly to check my ARP table and MAC address table and get this information. The layer 3 switch doesn't need to send out the ARP request again to get the PC2 MAC address because I already recorded this information into the forwarding table. And of course, after PC2 receives the ICMP equal request message from the switch, I will send out the reply. When the layer 3 switch receives the reply message, I will also do the de-encapsulation and according to the destination IP address 192.168.10.2 to check the forwarding table and do the re-encapsulation again, then send the message to the PC1. So we will find the last result is PC1 and PC2, the connection is successfully. So this is the full step. All the subsequent packets are directly forwarded by the hardware after checking the MAC address table and the layer 3 forwarding table. So this is the whole process. This is a basic function of direct routing. If you have this routing information, you can help forward the message between different VLAN, VLAN 10, and VLAN 20. So this is the basic explanation about the direct routing.